Hello friends, I am Ranjit Dhunde. Welcome back to the lecture series on the topic Laplace Transform. In today's lecture, we will discuss two important properties of Laplace Transform, that is multiplication by t and division by t. Now property number 6, multiplication by t, it states that if Laplace transform of f of t is equal to f bar s, then Laplace transform of t times f of t is equal to minus d by ds f bar s. Now it's proved. So this is the given part. Laplace transform of f of t is equal to f bar s. Now by definition, Laplace transform of f of t be the integration 0 to infinity e to the power minus st f of t dt, and it is denoted by f bar s. अब हमें प्रूफ में चाहिए डेरिवेटिव ऑफ f bar s. तो फॉर दिस वी डिफरेंशिएटिंग this with respect to s. So therefore d by ds integration 0 to infinity e to the power minus st f of t dt is equal to d by ds f bar s. Now by using the differentiation under integral sign, so this d by ds means derivative of this e to the power minus st under integral sign, that is integration 0 to infinity. Now derivative of e to the power minus st, answer is e to the power minus st into derivative of minus st with respect to s. So therefore answer is minus t. This f of t as it is, dt as it is, e is equal to d by ds f bar s. Now this minus sign taken outside the integration, minus integration 0 to infinity, this e to the power minus st, this t f of t, t times f of t dt, and is equal to d by ds f bar s. Now by using the definition of Laplace transform, this integration be the Laplace transform of t times f of t is equal to d by ds f bar s. Now the answer is Laplace transform of t into f of t is equal to minus d by ds f bar s. Hence proved. This is the proof of the Laplace transform of t times f of t is equal to minus d by ds f bar s. In general, Laplace transform of t to the power n times f of t is equal to minus 1 to the power n dn dsn f bar s. Now we find Laplace transform of t times cos t. Its solution. In the previous property, we already proved that Laplace transform of t times f of t is equal to minus d by ds f bar s. Now here let this f of t is equal to cos t, and therefore Laplace transform of f of t is equal to Laplace transform of cos t, and therefore this Laplace transform of f of t denoted by f bar s, and Laplace transform of cos t, answer is s upon s square plus 1. Therefore Laplace transform of t times cos t is equal to minus d by ds f bar s, means s upon s square plus 1, s upon s square plus 1. Now by using the quotient rule of differentiation, minus sign this denominator as it is s square plus 1. Now derivative of this numerator means derivative of s, the answer is 1, minus numerator as it is, derivative of this denominator means derivative of s square plus 1, the answer is 2 times s upon denominator square, the s square plus 1 whole square. Now simplification is equal to minus Now s square plus 1 into 1 means s square plus 1. S square plus 1 minus s into 2 times s, answer is 2 times s square upon s square plus 1 whole square. This is equal to s square minus 2s square, answer is minus s square plus 1. Now multiplying this by minus 1, the answer is s square minus 1 upon s square plus 1 whole square. So this is the Laplace transform of the t times cos t. Now property number 7, division by t. It states that if Laplace transform of f of t is equal to f by s, then Laplace transform of f of t by t is equal to integration s to infinity f bar s ds. Now it's proved. So we denote this f of t by t is equal to g of t. So let the g of t is equal to f of t by t. Now cross multiplication. This implies that t times g of t is equal to f of t. Now taking Laplace transform to both sides, the Laplace transform of t into g of t is equal to Laplace transform of f of t. Now Laplace transform of t times g of t, the answer is minus d by ds g bar s is equal to Laplace transform of f of t is equal to f bar s. Now for this integration, integrating this with respect to s from limits s to infinity. So therefore its integration be the minus g bar s and limits s to infinity is equal to integration s to infinity f bar s ds. Now if we put this upper limit infinity in g bar s, we get the answer 0. So upper limit is 0, minus minus plus, and lower limit is g bar s is equal to integration s to infinity f bar s ds. Now this g bar s be the Laplace transform of g of t, and this is equal to integration s to infinity f bar s ds. Now g of t, the g of t be the f of t by t. So therefore Laplace transform of f of t by t is equal to integration s to infinity f bar s ds. This is the proof of the Laplace transform of f of t by t is equal to integration s to infinity f bar s ds. Now let us see the example based on the property division by t. Now this is the example 1. Find Laplace transform of sin t by t and hence evaluate integration 0 to infinity sin t by t dt. Now we know that Laplace transform of f of t by t is equal to integration s to infinity f bar s ds, and this f bar s be the Laplace transform of f of t. Therefore Laplace transform of sin t upon t is equal to integration s to infinity. Now this f bar s be the Laplace transform of f of t, here f of t be the sin t. Therefore Laplace transform of sin t ds. Now Laplace transform of sin t, answer is 1 upon s square plus 1 ds. Now integration of 1 upon s square plus 1, the answer is tan inverse s, and limits s to infinity. Now upper limit tan inverse infinity minus tan inverse s. Tan inverse infinity, answer is pi by 2 minus tan inverse S, and this is equal to cot inverse S. So therefore this cot inverse S be the Laplace transform of sin t upon t. Now we evaluate this integration. So this integration is denoted by I is equal to integration 0 to infinity sin t upon t dt, denote it by equation 1. Now by definition, Laplace transform of sin t upon t is equal to integration 0 to infinity e to the power minus st and sin t upon t dt. Now if this s is equal to 0, then integration in 1 is equal to the integration in 2, and therefore from equation 1 and 2, this integration I is equal to Laplace transform of sin t upon t at s is equal to 0, and Laplace sin t upon t is equal to cot inverse s. So this is the cot inverse s at s is equal to 0, and therefore this answer is cot inverse 0, and this cot inverse 0 is equal to pi by 2, and therefore integration is equal to pi by 2. That means integration 0 to infinity sin t upon t dt is equal to pi by 2. Hope all of you have understood the topic. Please subscribe the channel and let me know your comment and feedback. Thank you. Have a nice day.